Okay, the agenda for today, we'll have an introduction by Jay from Equus, and then Ben from NVIDIA will take us through the power of NVIDIA and the hardware that we use for this Gen A workflows. And then we'll pass it to Brian and Denise to talk about the RAVEL intro, multi-model, and demo. And then Jay will wrap it up with a conclusion. And then, as I mentioned, we have a Q&A situated at the end, about 5 to 10 minutes to go through any questions that you might have. I'd like to introduce the speakers for today. Jay Lawrence, who's the CEO of Equus. Patrick Pedroso, Senior Director of Engineering Solutions at Equus. Ben Siegel, Solutions Architect at NVIDIA. Denise Moiko, CEO, founder of RAVEL. And Brian Burke, COO of RAVEL. And with that, I'll hand it over to Jay.
So, hey, listen, this is a really exciting solution we're going to talk about today. And from the ECS perspective, we've been around for a good while. Our DNA is rich. We understand solutions engineering. We understand how to make things work. And when Denise and Brian get to talk, they're going to probably want to share that there is some real secret sauce in how things are made to work and works. Can't cost extra, but it has to actually be real. And what you're going to see is real. For the last 30 years, Equus has been in the systems integration and solutions engineering business. We work with the best of the best. And really, we're very thrilled to be here with RAVEL and with NVIDIA today, because part of our future, most of our strategy, and our DNA of the past is all migrating towards innovation. What we are focusing on as a business are these key areas, which, by the way, they are independent lanes, and things like AI and machine learning, telecommunications, and then also immersion cooling, which, as you start thinking about very high performance computing applications at scale, at some point, the chips have already gotten so hot that fans are becoming antiquated. It's the buggy whip to the Model T. So our view here is, as the connective tissue and standing behind RAVEL as a killer application in the software world, to get into the generative AI space, all powered by NVIDIA, is really key to our approach and our strategy to how all this comes together. So ECS has, again, we demonstrated it for years, for decades, but more and more we've invested substantially in our engineering capacity as a business, substantially to empower and enable and accelerate bringing to market solutions like RAVEL. They kind of had a media flavor to them, but the thing is, there's such a wide berth of areas that they can touch. But in order for that to be successful, somebody's got to make it work, and that's where we come in. So it is that right tool for the job. It is understanding how to develop it, and also giving customers, all you listening and considering RAVEL, giving you guys the opportunity for that scratch and sniff. So our innovation facility is up. As I said, this application is running. It's running right now on the NVIDIA A100 platform. We built a cluster to roll this out and let people come in and try it. Again, most important, it works. It's ready now. But beyond that is, when you look at the best tool for the job as an ideological component to how do you do things, what's most important is, with our innovation strategy and being that connective tissue between the killer app at RAVEL and the best-in-class accelerating components with NVIDIA, you have to have that glue to contextualize how and why and what gets built. And that's us. So it's not just a case of the fact that we have this running now. It's the fact that we are able to think on our feet, adjust, build very bespoke solutions for folks that have different needs and different workloads. This is not a one-size-fits-all operation. Socks don't work one-size-fits-all, so why should you assume generative AI would have that component to it? The other thing that I think is important about us is because we've been around for a while and we work around the world, we have a global footprint. So it doesn't matter where you live, ECS can support you in your RAVEL journey. And that is and ought be something that you think about and consider, because in Denise and Brian's work to put this syndicate together, their consideration was not just how do I push some software out into the market, it was how do I make a lasting and meaningful imprint in this space. And we're very pleased to be, as I've said repeatedly, an actor in a supporting role. Denise and Brian are up for Best Actress and Actor. We're just here to make sure they look really good. So when you take the capacity that we've built as ECS, and the fact that one of our primary goals is a customer first ideology. Now, people talk about customer first, but we mean it. And that means we're looking at, one, making your product lifecycle journey very meaningful and simple and easy, but we're also very flexible in engagement and engagement models. The most important thing from our perspective is to stand behind RAVEL, because we believe that this technology is something that's going to have great impact in multiple market verticals and enable our customers, our shared customers, ECS's, RAVEL's, NVIDIA's customers, to have outcomes that are substantially improved by this engagement. So while we have all this capability, we're not talking about vapor, because this works, it's live, and you're going to see it in a few minutes. I'm going to ask Patrick, who's on the call. Patrick heads up our solutions engineering, and he's been with me for a good long while, and I can't quote myself. So Patrick, you might want to just take the baton here. And for those watching and listening, pay less attention to the bullets than the words. The key thing here is that we have a full product lifecycle, full engagement structure and model, that whether you're doing this as a trial and a test, or you're doing it at scale and you need to be in an immersion tank for your ESG scorecard, or to save the power, or to protect the devices that are enabling this, ECS is the partner in this that creates that connective glue. So Patrick, over to you.
Thanks, Jay. So yeah, as Jay was saying, the quote here, we chose to partner with RAVEL Orchestrate, to accelerate access to our customer first mission that he was talking about. RAVEL is, the solution, to enable access, to our capacity, as well as the way to rapidly deploy and stand up solutions quickly. So in that, we do have hardware solution design, our innovation center, where we have all this staged. Customers can come in and trial, eval different solutions. We have rack and tank integration. Basically, that's from, building out. We can build out the solution in an air-cooled or immersion-based solution to go and test this. I think Jay mentioned in the beginning that the TDPs of all this equipment, the GPUs and everything is getting hotter, so we have an environment to go and test that in. We also, as he mentioned, we have the staff on board for design for the integration services to help facilitate that. We also have large deployment global capabilities. It's also the cradle to grave support. We have low-level engineers to kind of help with tech support, all the way up to rewriting and software as we need to. We also leverage automation and orchestration, like the RAVEL tool, to enable all these capabilities. So, and on top of that, we also have the software and engineering resources to kind of help push this forward. So,
good stuff. So, summarizing all these bullets, and again, the bullets are the bullets. The fact pattern here is that we collectively have proven that we can build this solution out. ECS is here again to stand behind RAVEL with NVIDIA. This is all the title of the slide is most important. It's why us. It's powered by NVIDIA. We can make this work. I'm going to pass the baton to our good friend at NVIDIA, Ben. So Ben, over to you to talk about the NVIDIA piece.
All right.
but I'm sure everybody is most excited to see the demonstration. So it's your turn. Have fun.
All right. Can you see my slides? As mentioned, I'm
You're
Ben
good.
Siegel. I'm a solutions architect at NVIDIA, and I have my good buddy on the sales side, Stu, being with me. And I'm really just going to cover three quick things here. The first is the data center platform, the GPUs being used, what they look like, and the value proposition of them. We do have the RTX vGPU platform because just because you have your data center GPUs doesn't mean all solutions will fit with your data center. Some of them will, as in with this demo, we'll see how the vGPUs are used as well. And then thirdly, I do have a slide on NVIDIA AI Enterprise to kind of bring it all together, but it won't actually be in that order. So getting started with NVIDIA kind of holistically, we're an accelerated computing platform, right? So what we're doing is we're creating these GPUs that really excel in parallel processing rather than your traditional single thread processing that you'd find in CPUs. And this really allows you to accelerate what happens behind the scenes with deep learning, machine learning, large language models, and generative AI, of course. So what we have here is a full stack solution, right? But just because I say full stack solution doesn't mean we don't need any other players, which is why we're all here today. Because these other players that you see on the call here are we're part of their full stack solution, they're part of our full stack solution. It's a great back and forth relationship. So when running machine learning, deep learning, and LLMs, you've got to take in consideration the system you're running on, which was mentioned earlier, the A100. And then you have your acceleration libraries and then the applications themselves. And in this case, the applications will be running on the vGPUs passed over and whatnot, but I don't want to spoil the demo, so I'll just keep it to NVIDIA. So we've got three main things you see here, but we're really only focusing on the GPU today. But the point is there's more than one solution to a problem. And then, of course, when you're looking at the trajectory of where AI is going with large language models, we have various GPUs that do fit for that, and you'll see that on the next slide. But in this one, you can just kind of see the trajectory and how long it takes for certain GPUs to train. Now, that doesn't mean you have to go with a certain GPU over a different GPU. It really depends on use case. It depends on so many various factors involved. So when looking at the GPUs that are in our current lineup for generative AI and large language models, we've got a couple. Some of them you may have heard of, some of them you may not have heard of. But the point here is that there's not one good GPU for every single solution. Some solutions may only require an L40S or an L40, where you would find lower parameters, you have billions and billions of tokens, but you may not need all of that capacity. Our current flagship GPU is the H100, and you'll find that in various form factors, such as the SXM and PCIe. That GPU comes with 80 gigs of RAM, whereas the L40S, for example, only comes with 48 gigs. So as you can see, there are different price performance guidelines that will help figure out what is the best GPU for the workload. And you'll see that even though we're using a very specific GPU in today's example, it's a very good GPU, and we'll talk about that later. So at a high level overview, the way we're seeing the market going is LLMs and generative AI is a very robust and important industry. And we're forming these GPUs around, we're shaping how these GPUs work around what we're seeing in the future. But just because we have GPUs dedicated for Gen AI and large language models does not mean those are the only GPUs available. So this is a graph. It's an eye chart and a lot of numbers, but you don't really have to focus on it. I just want you to see in the columns here some of the various GPUs that could be used for different workloads. So for example, like I said, the flagship GPU right now is the H100, but it's also the most power hungry. It also has the most cores. And something you'll notice as the generations of GPUs increase, where right here with the H100, we have the Hopper generation, the L40S, we have the Ada Lovelace generation, and then all the A GPUs you see here are part of the Ampere generation. Something that's really important to recognize about the Hopper generation made of Lovelace is that it has the transformer engine, which allows you to dynamically convert your code base from FP16 to FP8. And you can see on one of these rows here where not all of the GPUs even have access to FP8 cores, and that's because they don't have the transformer engine. So when you're running generative AI workloads, it's important to understand what kind of code you're running, what models are you running, your transformer engine, how that's operating, and all the other things included. Now, of course, just because the Ampere generation is not the newest generation does not mean it's not a very viable GPU depending on what you're looking to do. For example, virtual desktops, graphics, etc., which will be covered in this demo as well, because it's not just one solution not one GPU fits every solution. So just taking a look at the different GPUs, it is a lot to consider. And as time goes on, this is a dynamic chart. It will change over time. So just keep in mind that when selecting GPUs for the workload, it's important to understand the workload. It's important to understand the frame buffer and pretty much everything that goes into it. So with GPUs in mind, it all wraps up together with NVIDIA AI Enterprise. And this is a full stack solution that we provide that actually fits with the partners we have here. And this isn't just go with NVIDIA and everything's cool, all said and done. This is in collaboration with many, many, many partners. There are other slides that go much deeper into that, but I figured this would be a great high-level overview of what you're looking at when you're running with NVIDIA GPUs and other solutions. You start off with your infrastructure on the bottom. Where are you running it? How are you running it? What kind of GPUs, your networking, your storage? Just because you have a couple of GPUs in a server box doesn't mean you have enough power and capabilities to run all your workloads. There's a lot of other factors to take into consideration, like networking and your storage, power consumption, because the A100 and the H100 are very power-hungry GPUs. We're looking at over 10 kilowatts of power. So then how are you going to manage these GPUs? Just because you have the GPUs, you're not going to turn on the server, log into a GUI or the command line, and just start running. Some servers allow you to do that, but most of the time you're on your own trying to figure that out. And that's where our partners really shine and come into play as well. So what kind of orchestration and management are you working with? But then once you get your GPUs up and running, now you have to actually deploy something. And what you'll see is something actually being deployed. And so what kind of platform are you deploying? How are you deploying it? And what processes are you running to do that? And then at the top, we have our workflows, frameworks, and pre-trained models. NVIDIA is kind of split up into three large categories right now. We're hardware, we're software, and we're networking. You can't run Gen AI and large language models without a combination of all three. Which one is more important than the other is up to your discretion. All we can do is provide you the facts and knowledge surrounding what you're looking to do and how the infrastructure works. But NVIDIA AI Enterprise provides the ability for you to be able to manage your workloads, as you'll see with our partners here. And it's where you'll get your support, and basically it's our entire ecosystem surrounding our GPUs and our infrastructure. And then the last component we have is the vGPU software. And this is important because you're not going to be running software straight on something like an A100 or H100. They're the power horses. They're the ones making sure that you get the results you need in the time you need it. So what we're looking at here is vGPUs. And if we actually go back to this chart, you'll see some of these are vGPU compatible, such as all the A100, the A30, the A4, etc. But there's also the RTX, the Quadro RTX lineup. And if you're familiar with RTX, there's two kinds of RTXs. There's the consumer side, and then there's the vGPU side for visualization and virtualization. So we're focusing on the Quadro RTX in this case. And there's a couple of different licensing that allows you to figure out what kind of workloads you're running, such as vApps, VPC, and workstations. And this will say whether this will take the application you're running, virtualize it for you so you can split up your GPU dynamically within the virtual workstations and allow you to distribute the resources as necessary. So you can split up 48 gigs of VRAM as needed based off the vGPU profile. So some of the workloads that you can run, for example, are split up between knowledge workers with scalability and creative and technical professionals with performance. And this is not an inclusive list. There are many, many, many more programs, systems, softwares that can be run in a virtual workstation. But the point being is that if you need to run something and it requires a GPU, you don't have to take the entire GPU for one user and give them the entire thing and say, hey, sorry, when I'm done, you can have it. You can split it up as necessary so that everybody has access to the GPU, whether at the same time or you distribute it as necessary. So you may recognize most of these, you may not recognize some of them. And again, this is not an inclusive list, but this is where we find vGPUs to be mostly used. And then just a little bit about how vGPUs work. You're taking the GPU itself, you're putting it on a server, right? Because else you're going to run, and you've got your storage and your networking. And then with your hypervisor, there's a lot of hypervisors that you can use. It's not just VMware with vSphere, et cetera. There's a lot. So you take that vGPU and then you split it up and you separate it out so that all of your frameworks are there ready to go. And you don't have to worry about CUDA drivers. You don't have to worry about the GPU driver, CUDA libraries, because pretty much all of our software and a lot of software that you would be using on an NVIDIA GPU runs with CUDA. And so what you're seeing here really is just kind of that very high level. You take the virtual works, you take the GPU, you put it on the server, and then you run a virtual workstation application. And then that can communicate back with the DGXs, HGXs, any kind of hardware you're running. I also did forget to mention NVIDIA certified servers. So there's so many different ways you can take these pieces and put it together. It's almost like Legos. There's not one box that works for everyone. So we have certified servers, we have HGXs that allow you to say, hey, I need X amount of GPUs. I need this kind of performance, build it all together, get it up and running. And now you're able to start running your workloads. And then you do see the piece here for NVIDIA AI Enterprise. That's also because all of the support, where you get your drivers from, where you get your tools and capabilities. For those who haven't seen it, NVIDIA GPU Cloud NGC is another resource where we host containers. So when you're running your workloads, you have a one-stop shop for figuring out what you need to run. And then you can use this entire ecosystem that you're seeing on this webinar here to really get your applications, the performance of your applications up and running at maximum potential.
So, hey, Ben, just to jump in, because this is a lot of great detail. And it kind of goes to my opening point. This stuff is built to work, but it's complex.
Yes.
And this is why the syndicate that is together here with all the tools and all the capacities that NVIDIA brings to the market and to the table here, works can't cost extra. I say that all the time to my customers, they expect works. And that's why the three of us as partners in this endeavor really make up the difference. As Denise and Brian go into the demo, I think the key thing for anyone who's trying to understand these complexities, because there's a lot of choices, you just outline them. We help make those choices linear and simple. Even the eye chart that had a lot of really good information on it. For the person who's trying to make something look pretty and do something really cool in a media world, they're going to get frustrated by this. We can take that frustration out and make this all very, very simple.
Exactly.
So, Denise, I'll let you take it from here, but I just wanted to chime in with the observation that there's a lot of moving parts to make this go, but the good news is we've already made them work.
I would like to say one more thing, that AI is complicated. Gen AI is even more complicated, and large language models are crazy. So it takes a lot of people. There's a lot of tech personas, a lot of business personas involved, and not one company, not one individual can do all of it at all. So it takes a lot of moving pieces, a lot of puzzle pieces to make this work properly. And we're just one piece of that puzzle.
And hopefully Equus and RAVEL will be able to answer all the rest of the questions. So it's good to see everybody again. It's been since NAB and CGraph. I've seen a lot of you there. So I know the majority of people that are in this webinar. So it's great to have you with us. And for those that we don't yet know, welcome. Again, what we're going to be covering today and what our focus is today, although we covered lots of different segments, our focus is going to be on the content creation industry. So that includes media and entertainment, product design and manufacturing, AEC, gaming, and advertising. So that's code for, we really have expertise in complex workflows and heavy workloads. So before I kind of get into and hand this off to both Brian here to go over the demo, I'm going to basically go over, kind of define what I'm going to call the red thread, right? So the red thread is like the why we're here, and we are here to discuss generative AI and generative design. And as we all know, everyone is going to be handling and implementing generative AI in some way, shape, or form. What we really bring to the table together, this solution that the three of us are putting together, is the easy button. RAVEL Orchestrate in specific is the easy button. So all those fancy things that Ben was talking about, we try to simplify that with the help of our partner Equus. So the thing that I think is important is showing you guys a practical implementation, how this can work within a workflow, and having that ability to implement this easily, but then have it also be transparent, so you guys are well aware of what's going on. So it is pretty common that like as Ben was talking about, a lot of this is pretty complicated and could be overwhelming. And when we get into like the practical application, all of you guys, I've talked to most of you, all have that issue of being ESG compliant. How are we going to manage that carbon footprint? So we can talk a little bit about that and some fancy, what I would say, advanced cooling is definitely on the table. I know that is something that Jay and his team at Equus are really investing in and helping that happen. But I did want to talk about the real truth, so to speak, and that real truth being that generative AI, yes, it's complex. Yes, we can make it easy, and then we could talk about the authenticity, content authenticity, and provenance, and that is a big deal. Most of you, I've talked with a lot of you guys, both at NAB and at SIGGRAPH. Brian is also becoming a resident expert here, dealing with and understanding deeply about what are those issues, and making the generative AI results, the content, that the results there, making that quote legal, like how to protect that. So that becomes the forcing function, right, of dealing with on-premise solutions. Yes, RAVEL Orchestrate can work in big data centers that Equus has deployed and can deploy, as well as hyperscaler clouds. But our focus right now is to talk about our on-prem solution here. So I'm gonna go ahead and start with a quick introduction about what RAVEL Orchestrate does and what it is, who we are and what we are. So most of you guys know who we are and are using us right now. But again, we are a no-code orchestration for deployment and management of secure environments. It's we talk a lot about content creation, and we know all those pains and aches that your teams feel, and so we're here to make that easy. We are the easy button to assemble all those components. So let's get into the 4 components. Many of you guys have seen this as well, but it's the big 4, right? It's all those content creation tools themselves, your Autodesk, your Avids, your Adobes, your Founders, etc. We can also get into the generative AI tools, and we'll show that to you in the demonstration. That's the first component. The second component is dealing with the infrastructure itself. You've got your on-prem infrastructure, and we are going to show you, and you will be able to touch and feel and demo yourself within Equus's innovation lab. That's what we're going to show, and that's what you're actually going to touch. You're going to touch that actual model. And then the third component is those virtualized tools. So we don't have a horse in this race right now. We're going to show you specifically HP Anywhere, which most of you guys either have or do touch Teradici, or I should say HP Anywhere Parsec. Some of you guys use ESXi. So those are things that we interoperate with. And then there's that fourth component, which is, of course, dealing with Active Directory usually, or Okta, or some other custom identity management and access control. So that's what we rapidly assemble. Some of the features that we're going to show you that you're going to have access to is these are the big features of Orchestrate. So one is how to assemble rapidly and quickly those images, those software images. In our industry, it's very often that we're dealing with project-based and team-based environments. It's getting the right image to the right team on the right infrastructure. So it's about creating that image, quickly and rapidly deploying that image to infrastructure. That's what you see in number 2 there. And then number 3, we take that infrastructure and all of those we'll put them in pools. It doesn't matter if they're server pools, render pools, workstation pools. You take those and you put those into pools, and then you assign those pools to teams and the human resources that are actually going to be executing whatever that function is. Then the fourth thing is the actual schedules themselves. Schedules are important, especially when you're dealing with, on-premise, because sometimes that infrastructure is being used for multi-purposes. So it's that ability to, number one, configure the right machine to begin with, right? What does that machine, what does that constitution of that machine look like? And then the ability to assign that image and those people to that particular what I'll call it a schedule, right? And then the last component is telemetry. Everyone wants to know, in our industry, everyone is curious about and wants to know what are people's time associated with that? How long did it take to do that particular shot or that image or what have you? That's really important. We can get more into that, but that's primarily used for the VFX super or whoever is the person that wants to know that information. It's also used for operational efficiencies as well. How efficient are we using our tools here, our infrastructure tools? Okay, so one of the things while Brian's getting ready to set this thing up, I did want to talk about why people like us, why people are using this. What are the 3 common use cases? It's really about creating efficiencies and reducing that friction, right, for DevOps and IT teams, right? And being able to enable their end users. That's the number one use right now that we're seeing with our customers. The second piece that's important to that, the second use case, is what was onset by the pandemic and the concept of remote workers, right? Everyone used to have to come in physically, but now, the pandemic really kind of enabled people, and we saw there's lots of problems that have been solved because of the remote work. And now a lot of you guys can follow the artist. So it's not so much about physically being on-prem, although that is still a big part of the industry, but it's people need to follow the artist, follow the engineer, follow the designer. That's the second use case. The third is about specific modules, and we will also talk about that as well. The modules being, in this particular case, we have a generative AI, generative design module, where you can take some of those things that are off the shelf and you can play with those. You can also, if you're dealing with custom models, that you can enable that as well and easily deploy that through Orchestrate. So I'm going to now pass this over, and Brian is I'm going to look over here, and Brian and I are going to give you a showcase here. Is that not showing?
Yep.
Okay.
Showing. Can everyone see it? Yep,
Yeah, everyone can see it. Okay.
Okay. So what we're showing here right now, in the spirit of what Jay was saying, is it's something that's actually deployable and that you will have access to in a trial or POC that you can sign up with us. This right here is a deployment on Equus's Innovation Center in just outside of Los Angeles. Now we're based in Seattle, and what we're going to do is show you different versions of Orchestrate for the purposes of explaining some of the functionality. This one in particular is a bare metal installation on Equus's Innovation Center. This is what's powering the generative AI workflow, and it's on a liquid-cooled box, and then there's other supporting infrastructure as well. So what you see here in every case with RAVEL is the first thing that an administrator would see. This is an administrator license. You would see actually the dashboard. This is your single pane of glass, and this is what you would see within a POC or trial when you do that with us. It gives very quick information about your license, how much consumed workstation time, your workstation resources, how many total workstations are there, how many workstations are in use, how many ones are running, and then also servers as well, particular user accounts and provision regions. So in this case, for the POC, we would give access to 4 different workstations with specific software stack on there for the generative AI workflow, but yet at the same time, you're also able to access this with your admin functionality. Some of the key areas here, Denise, obviously we're talking about this. We are using for this specific trial in this instance. It actually is using HP Anywhere. You also, with those 4 workstations, you take a look at the 4 workstations that actually have been provisioned. So keep in mind that what we're seeing here right now, this is actually a single super workstation wherein we are actually virtualizing 4 A100 cards and providing access to 4 different workstations within this one super workstation. It's a very unique implementation. And of course, Equus can do similar type of deployments depending upon what your needs are and your requirements. So with these 4 different workstations, they each have a different image on them. They have a specific VDI, and they're all part of different pools. Every workstation, when it has been provisioned, then can be put into a pool. This is part of the workflow that Denise mentioned, is that in this particular case, there are 4 workstations within the super workstation that's been virtualized, but Orchestrate can manage hundreds or thousands of your workstations. But for this particular instance, it is just these specific workstations. For the purpose of this, we've also created workstation pools that are specific to each separate workstation to provide persistent information and data for the people that will be trialing this. Once a workstation has been added to a pool, then you want to give people access to that pool. So specifically within RAVEL Orchestrate, we give you the ability to assign users via your Active Directory or other tools that we mentioned before, but primarily for this one, it is Active Directory. You are able to add people, you're able to remove those folks, and those are the folks that actually will have access to these different workstations. You then put those users into teams. It's very important to have teams because teams can be part of projects. Let's say, for example, some of the folks that we've met who are probably on this call, you have a specific production, and that production is maybe, if you're a VFX house, there's specific work that needs to be done with a specific stack, and you want to have a team that only has access to those workstations in that pool at a specific time. So for this purpose, we have 4 different teams. You can actually add other folks to these teams as you see fit, and then you can give them as much access to this compute as you see fit. Why is that important? It's important because in some cases, if you're a services-based business, maybe you're a VFX shop or post or previs, you have specific timelines that you need to hit. And so you're only going to have specific access to at that point. So once you've actually added people to teams, you actually can assign hours to them, and then you can schedule their access to that compute, all right within this single pane of glass, all within Orchestrate. So I have everything running right now. We have everything running right now in this Equus POC, but you have the ability to drag and drop and schedule whatever you need as far as access for those teams to those workstations, specifically within that instance. Anything to add there, Denise?
I think you caught it.
We also have reports. The last thing that's really important, we talk about the telemetry, that's the one thing that we end up with. After you've gone through the full workflow, you will actually be able to check and see which user on which date, part of which team, and you would know what software stack was on that and for what duration they are accessing those workstations. That's real important for a lot of teams to be able to have that level of telemetry. Now, what we want to do is talk a little about the future state here. So Denise, why don't you talk a little bit about our generative AI model?
So what Brian just showed you is what you will all have available to you. And we'll get you guys access to that. This is an option, right? We're not going to be able to do what we're showing you right here, which is this generative AI module that we have, because we don't have the capacity with this particular POC. But I talked to Jay about this, and Jay is willing to increase that capacity to have people try this out. So just let us know, and we will give access. We'll get you guys set up separately with this particular module. Now, this module is using the usual suspects with Stable Diffusion, right? There's some, we'll have Midjourney, etc. This is what's up right now, but basically it's you choose your usual suspect, model, and then if you have a custom model, there's a button down there that says basically install your custom AI engine, and we will basically manage that as well and package that up and then be able to deploy that onto your machine or the machine that is part of this network. So that is coming, well, it's available, but again, just let us know if you want to try this out. The third thing that we wanted to show you, so is what is coming with our on-prem solution. So we have multiple ways that we can deploy RAVEL Orchestrate onto different infrastructure. So obviously on-prem is big for us. In data centers, right? Similar kind of behavior, but also in the cloud, we have something that's called Build Station. Build Station is coming to our on-prem solution here in Q1. And so we wanted just to show you what Build Station really is. And there is a way to do this manually within the on-prem environment, but our solutions are pretty elegant. It's just a couple of clicks here. So basically, it's all about creating a new master. It is about selecting. Here you can see this is a GPU. We also have an Avid, and we're running an Avid module as well. There are certain modules that we have, but it's we're running GPU. We're running, basically you could see the type of virtual machine. These are the NV series this happens to be within Azure. But all of this is about how to quickly or rapidly assemble software images that people need to change. And everybody on this call knows what the pain is when you're trying to make an adjustment to a software image because you need to add a plugin or a script or something else that is either expensive, or you might only have a license, a couple of licenses. So this gives that opportunity to quickly and rapidly deploy and adjust those master images. So Brian's kind of going around like what are all the inputs. So the next thing I want to basically show is that we're showing basically 4 different, right here you see there are 4 different images. If you want to make similar, that's one of the best features, because you have a base image, you want to make similar, you can click on that. You don't have to rebuild the image again, and you just you open up that image, you add that image, and there you go, and you're ready to deploy. There's no issue anymore with having to stop and have the IT teams, 2 a.m, make those adjustments. This is all on the fly. It's all easy, no disruption to your teams. That's really what it comes down to.
And that's a good point, Denise. The purpose for this is that we want to show you the future state and what will be available to you. And with the actual POC and the trial, what you have available to you within the Equus Innovation Center, this is what will be coming soon. Yeah. But for the purpose of this trial, we want to give you a view on what this looks like. So what you see here right now is it's all tiled, right? But we have 4 different workstations running. Each one of those workstations has Photoshop on it. It has access to Stable Diffusion. It has the Stable Diffusion plugin as well to be able to run Stable Diffusion within these different workstations. And we're using multi-model here too, because we'll actually show what you can do with an Adobe Firefly as well after you've generated images. So these are 4 different workstations that I'm accessing from Seattle right now, and they all live within that one workstation, that one super workstation that has been virtualized. So I'm right away going to generate 20 different images utilizing the Stable Diffusion plugin in each one of these different workstations. Now, for anyone that is currently using generative AI, any one of these tools, you know that it takes a lot, and you need the speeds and feeds to be able to actually generate these fast. This type of frequency, this type of path is so substantial. You're seeing how fast this is being done. That's because of the power of that NVIDIA compute. So maybe Ben, can you mention a little bit about, these are A100s what we're using right here, but maybe speak a little bit about to the rate, a little bit more about that.
Yeah, so these A100s, each one to one, right? Each of them have their own memory modules, right? So each one of these has 80 gigs of memory. So we're looking at like 320 gigs total. That's power being outputted. And the amount of cores being utilized here is probably not even maxing it out. You could probably even run more. These things are very powerful. So with demos like these are really good to see, because you're outputting at maximum capacity, but even these might not even be filling up the entire memory of a single A100. And as I talked about earlier, as you go on with the GPUs, this is still one of the best GPUs you can get.
And we're seeing the performance. This is what we showed at NAB and at SIGGRAPH. I just generated 80 different images. And so for, the use case, it's like, say, for a VFX shop, post-production, previs, studio, each one of your different artists has access to a different machine so that they can run their own prompts, etc., for the images that they need. They can then import them into whatever you want for performance. Maybe they need to put these into Maya. Maybe they want to put it into a different software. That's the choice they have. For the purposes of this presentation, though, and what you'll be able to do, you actually will be able to access all of these. So I'm going to show you now really quickly, in the spirit of the multi-model. One of the things, I don't know how many folks here have been using Adobe Firefly, but so for example, with this particular image, I can use Firefly, and you'll be able to do this within the trial and POC. And I can actually use different functionalities such as generative expand. So what that does, if any of you went to Adobe Max, it was pretty huge. It allows you to take an image that you've generated, say, from Stable Diffusion or a different model, and then mess around with it and do different functionality, because I'm right within Photoshop and I can export this to whatever other tool I want. So with Generative Expand, the great part about this is it's just created different views here. And if I want, I can actually then do Generative Fill. Let's say, for example, I probably wouldn't do this if this is sort of a Hobbit situation, but I'm just going to put a spaceship in there. Why not? It's pretty easy to utilize this functionality right within this demo, so you understand the power that you provide your different artists, whether it is with Stable Diffusion in this particular case, along with Adobe Firefly is another example. These are great tools for you to dip your toe in. As Ben mentioned, generative AI and implementations like this is pretty complex. And what we're trying to do here is simplify the whole process and create tools that are easy to use and functionality that is very accessible to you. What I'm going to do here real quickly here is I want to show where you can actually sign up. So this is a page here right now on our website. I will actually put the location in the chat. Here is the actual URL for anyone who wants to see this. I've just flashed that quickly, but we'll put in the chat in just 1 second. Right here, once you get there, you're going to be able to sign up for this trial, this POC. There's a little bit more information, links here to Equus. You'll be able to put in your start date and an end date. These are you requesting when you would like to utilize this POC and trial, and that is open to everyone who's on this call or your friends as well. There's a little bit more information about here, including options for the type of scope of what these deployments could look like. But Equus is here to help with any type of deployment and the functionality that you need.
Sounds good. I only have one substantial complaint, that the spaceship should have been a Star Destroyer.
Exactly.
Sorry,
Oh,
Star
that
Wars
is in the
fan.
chat now.
Can't help myself. Again, I think the key takeaway for anybody that is looking at how to is our mission here is to simplify this whole thing. ECS has got a lot of engineering capabilities. We're very tight with the folks at NVIDIA. RAVEL is a key partner that fits into our innovation strategy. And Denise mentioned this a little bit, and I'll just hit on it because there's a whole scale to this. People will start off wanting to tinker, wanting to evaluate, wanting to do the scratch and sniff. We got the lab and the innovation center ready for that right now. We'll expand that capacity going forward, because we believe this is part of what makes ECS valuable to the industry, and it is a 1 + 1 + 1 is much greater than 4. As these things scale, and those of you who do have concerns about ESG and your carbon footprint, our liquid lab is also right next to where this current AI cluster is set up, so we can both do both at the same time. And, you know, as Ben was going through his presentation, I think Denise did a wonderful job simplifying to the, you know, the OSI layer 7 application of what it is. The key thing is for all you folks that are trying to do and use and benefit and leverage this media capability, our job is to make your life easy. So ECS plus RAVEL plus NVIDIA, this is all put together so that we're standing alongside each other, and we're standing behind RAVEL as we see this as a killer app. You know, Denise made the point, and I want to just amplify the fact that this is actually industry ubiquity. There are so many needs and reasons and places and spots where this technology matters. And the great thing about this friendship, partnership, call it what you will, is that you do not have to be a rocket surgeon to deploy this. You just need to make a phone call. So glad to be the connective tissue, and I'm really excited to see what comes as a result of this. And we'll have more of these, by the way, because there's more being developed as we speak. But as a practical matter, while this is a very complex technology domain, our aim is to make, again, be the easy button. Make this simple, make it straightforward, be flexible on engagement, make the economics work, and make your outcomes successful. So I'll close with that. And Denise, back to you.
Okay. So are there any, I guess I'll go to Jeff, any questions that we have in, that we want to, that's posed here?
Anybody has questions, you can either raise your hand or type in the chat. Let's get it started with a couple of questions for RAVEL. Can you deploy more than one orchestrate, and how do you manage that?
Yes. So every deployment of RAVEL Orchestrate, think of it like we have a razor blade model, where if you are deploying it, let's just say you have one orchestrate deployment in one region and you want to deploy it in yet another region, or some people do it by project, or they do it by department. We have something that's called Boost, and Boost is kind of that overarching kind of, you know, commanding technology. It's that NOC, if you will. It's that interface that helps you both enable additional, as many RAVEL orchestrates as you so choose, and you can deploy that in any environment, as well as understanding the telemetry, and you can add extra seats, and you can go up and down with your seats for each RAVEL orchestrate deployment. So the answer is yes. It's called Boost. Is the way you manage that, and you also get telemetry on all of your orchestrate deployment, so you have that visibility as well.
Excellent, thank you. And then one more for RAVEL. Does RAVEL Orchestrate come in SDK?
Good question. So we have not officially put this in as an SDK. We don't have but we do have hooks, so it kind of looks like an SDK. But that's been a big request, and the answer is it's on the roadmap. Excellent.
Okay, switching to NVIDIA, how do GPUs speed up project productivity?
Well, it depends on the GPU you're using, but it largely goes down to the cores and the memory on the GPU. But just saying the GPU increases productivity it doesn't quite do it justice. It's about the software stack and the hardware. They have to work together with storage and networking. It's the full stack solution. So with the GPU, it's parallel processing. That's kind of the secret sauce there, but it's also the architecture. It's the other secret sauces that are built into it, like the transformer engine, the amount of memory involved, and it accelerates with software.
Great, thanks. And then one more for you, NVIDIA. How do you choose which GPU is best suited for your workload?
Start backwards, start with your use case, figure out what you're trying to achieve. There's lots of reference architectures and white papers out there, lots of work already done. Not everybody needs an A or H100, but it just depends on what kind of performance you're trying to get. So start from the use case and work backwards with how much memory you have, what your data set looking like, what form factor is it in, and then kind of compile that all together. And that'll give you a good idea of what you're looking for.
Great, thanks, Ben. Couple for Equus. Does Equus and Stratus Core offer POCs?
Yes, and you just saw the thing working live. So I think the link in the website that Denise talked about is something that should be looked at. Anyone who's interested. Moreover, it's not just POCs. This is a cradle to grave friendship with our customers, with RAVEL and NVIDIA. So what I would say to anybody who's got interest, wants access, wants to try, wants to test, wants to play around with, we're ready to go. It's live. It's ready to go now.
Great. And then another question for Equus: does ECS offer global deployment and support resources?
Yes, with the obvious limitations of the embargoed states that aren't very friendly to America, which we wouldn't want to sell to anyhow.
Thank you again for your participation in today's webinar. Thank you to the panelists for great presentations. There's a link that Brian has put in to the chat if you want more information to schedule a demo. Thank you for everybody, and have a great rest of the day.